This is Srinivasan, Assistant Professor in Mathematics Department, Sri Sairam College of Engineering. Today we will discuss the topic is Fourier module number 3. The topic is Fourier transform. This Fourier transform we discussed two subtopics. One is Fourier sine transform and another one is Fourier cosine transform. So we will discuss what is meant by Fourier sine transform and what is the Fourier cosine transform. After that, we will discuss the problem based on Fourier sine and cosine transform. So first we will discuss the definition of Fourier sine and Fourier cosine transform. So the Fourier sine transform is nothing. Fourier sine transform of f of x. The capital S into f of x is denoted by Fourier sine transform of f of x. That is equal to root 2 by pi interval 0 to infinity f of x sine sx into dx. This is Fourier sine transform. And next one, the inverse Fourier sine transform. So f of x equal to root 2 by pi interval 0 to infinity capital F of s into s sine sx into ds. So this formula is called inverse Fourier sine transform. And this two formula we can say it is sine transform pair. Fourier sine transform pair, as well as the Fourier cosine transform formula is f capital F c into f of x. This notation is denoted by Fourier cosine transform of f of x. Okay, that is root 2 by pi interval 0 to infinity f of x cos sx into dx. And inverse Fourier cosine transform formula is f of x equal root 2 by pi interval 0 to infinity Fourier cosine transform of s cos sx into ds. Okay, so this two formula is called Fourier cosine transform pair. Okay, so next we can discuss the problem based on sine and based on cosine transform. So the first problem, find the Fourier cosine transform. So find the Fourier cosine transform of f of x equal x divided by x. Another function is 2 minus x. Another function is 0. When the function is x, if the interval 0 to 1, the function is x. If interval 1 to 2, the function is 2 minus x. If the interval after 2 to infinity, the function is 0. So what is the question? Find the Fourier cosine transform. So we can use the Fourier cosine transform formula, that is Fourier cosine transform of f of x equal root 2 by pi interval 0 to infinity f of x cos sx into ds. This is our formula for the Fourier cosine transform. So see the here interval is 0 to infinity. In this 0 to infinity, I split three interval. One is 0 to 1, another one is 1 to 2, another one is 2 to infinity. So root 2 by pi interval 0 to 1, here function is x cos sx into dx, plus another interval 1 to 2, here the function is 2 minus x into cos sx into dx, plus another interval 2 to infinity, here the function is 0. So if the function is 0, the entire term is 0, we get only two terms, 1 and 2. Now apply Bernoulli's formula for the first term. We get x into sine sx divided by s minus 1 into minus cos sx divided by s square. And the second term, 2 minus x into sine sx divided by s minus into minus 1 into minus cos sx divided by s square interval 1 to 2. This root 2 by pi is common for the first term and second term. In the first term, substitute the upper limit. If you substitute the upper limit, we get 1 into sine, replace x equal to 1, we get sine s divided by s plus cos s divided by s square. So this is upper limit. Substitute the lower limit, we get substitute the lower limit, we get this is 0, and here cos 0 value is 1, so we get 1 divided by s square. Okay, this is the first interval. And the second term, so same as well as we can substitute upper limit 2 and substitute lower limit 2, we get like this one, and remove the brackets. So root 2 by pi, we get this line with this equation. Here, see, here sine ss, here minus sin ss. So these two terms cancel and collect the remaining terms. We get 2 cos s divided by s square minus 1 by s square minus cos 2s divided by s square. So base are equal, adding the power. So root 2 by pi 2 cos s minus 1 minus cos 2s divided by s square. This is our required Fourier cosine transform function. So next sum, find the Fourier sine transform of f of x. Here also they given 3 function and 3 interval. So now we can use sine transform formula. That is Fourier sine transform formula is root 2 by pi interval 0 to infinity f of x sine sx into dx. With 0 to infinity I split 3 interval, 0 to 1, 1 to 2, 2 to infinity. If you use 0 to 1 the function is x. If you use 1 to 2 the function is 2 minus x. If you use the interval 2 to infinity the function is 0. So the last function is 0. We get only 2 terms. So substitute the Bernoulli's formula. So this is the if you substitute the Bernoulli's formula, we get this equation. And in the second term, substitute the Bernoulli's formula, we get this equation. Substitute upper limit minus lower limit, we get this line. And here also substitute upper limit and lower limit, we get this one. Now remove the bracket, we get minus cos s divided by s, and here plus cos s divided by s. So these two terms cancel, the remaining collect the remaining term, we get 2 sin s divided by s square minus sin 2s divided by s square. Okay. Base are equal, adding the power, we get root 2 by pi 2 sin s minus sin 2s divided by s square. This is normal procedure only. If the question asking Fourier cosine means we can substitute Fourier cosine formula, or Fourier sine means we can substitute Fourier sine transform formula. Okay. See the next problem. Find the Fourier sine transform of e power minus ax, a greater than 0. Hence evaluate interval 0 to infinity x sine mx divided by 1 plus x square into dx. So first we have to find Fourier sine transform. If you want to solve the deduction, we can apply inverse sine transform formula. Okay, so first we have to find Fourier sine transform formula. By using Fourier sine transform formula, we solve the deduction by using inverse Fourier sine transform. So first find the Fourier sine transform and substitute the formula interval 0 to infinity f of x sine sx into dx. Here clearly f of x, a function is e power minus ax sine sx into dx. So this is root 2 by, this is the formula for the integral interval 0 to infinity e power minus ax sine bx into dx equal, the formula is b divided by a square plus b square. Here clearly b is denoted by s, so the formula is s divided by s square plus a square. So this is our Fourier sine transform. Now we have to solve the deduction. So if you want to solve the deduction, we can use only inverse Fourier sine transform. So by inverse Fourier sine transform formula is root 2 by pi interval 0 to infinity f of s into sine sx into dx. This f of s denoted by Fourier sine transform. What is our Fourier sine transform? Root 2 by pi s divided by s square plus a square into sine sx into ds. Clear? So root 2 by into root 2 pi, we get 2 by pi interval 0 to infinity sine sx divided by s square plus a square. And I take this 2 pi opposite direction, we get interval 0 to infinity s sine sx divided by s square plus a square into ds equal pi by 2 e power minus ax. This e power minus ax is a f of x, because our inverse Fourier sine transform formula is f of x equal to. Clear? So f of x is a given function, that is e power minus ax. So pi by 2 e power minus ax. Now compare the deduction and this equation. What is our deduction? Interval 0 to infinity. Here also interval 0 to infinity. Here x sine mx. Here x. So the first term is x. Here the first term is s. So I replace s equal to x. And come to next. Already I replace s equal to x. I want to m. So I replace x equal to m. And come to denominator. We get here 1 plus x square. But here a square is there, so I substitute a equal to 1 and s equal to x and x equal to m. If you substitute this value in the above equation, we get interval minus 0 to infinity x sine mx divided by x square plus 1 into dx equals pi by 2 e power minus m because a value is 1. So you just compare the detection and this equation and replace what you want the values, that values we can replace. Okay. So this is also same process, same problem. Okay. So thank you. Thank you.